Hello and welcome back to our webcast series on the topic of plane and descriptive geometry. So in this video we're going to look at how to define a set of parallel planes to contain two skew lines. So we'll begin by just discussing what this actually means and how to actually go about doing this on your drawing sheet. So we'll start off by just looking at a little sample here. Here we have two skew lines via elevation and plan view of the lines AB and CD, and here we have a 3D drawing of the same skew lines. Here just represented as two pencils, and if you actually have two pencils, you can just maybe use a bit of blue tack and just stick them to the table to use as a little model just to help you along if you want. Well, as we said, these two lines here are skew lines, which means that they're not parallel, which we can see that they're definitely not parallel here, and they don't intersect or cross, so they're skew lines. Well, one of the first concepts that I want to get across is that if you have two skew lines, there's always one view where the two skew lines will appear parallel. Not actually parallel, but they appear parallel. And if you take your two pencils and again just stick them to the table with some blue tack, you can follow this as well. So if we look at our two skew lines and just walk around the two skew lines, we can see there's always going to be one position where we look at it where the two will appear parallel. And as we said, they're not actually parallel. This guy is sloping away from us, this guy is sloping towards us, but we can see that they appear parallel. And well, what this means is that if they appear parallel like that, well, if we were to draw two lines cutting through them, those two lines would appear parallel. And well, this line here and this line here could actually represent two parallel planes. This pencil resting on this plane and this pencil resting on this plane. Two identical parallel planes. So let's just go to our 3D to see what that looks like. So you can see here's plane number 1, here's plane number 2. This plane can contain this line, i.e. this line is resting against the plane like a sheet of glass, and this plane here contains this skew line. So they're identical in every way, shape and form except for position. So really, if you can imagine taking this plane here and just sliding him across, you can imagine there he is. He contains the first pencil to start with, and now he's able to contain the second pencil. And this is important because there's only one possible skew line that can do that, or plane that can do that. If we look at our pencil here, first of all, there's an infinite number of planes that this pencil can rest on. So I could just maybe swivel that guy there like so. And you could say, well, look, that pencil is still on that plane, but if I was to move him across, he would never be able to contain this line. This pencil here would never be able to rest on it. And same way as I swivel it around to a new position, well, this new position can still contain the pencil, but he will not be able to contain this one here. So there's only one possible position that our plane can be in where it's able to contain this line and move across and then be able to contain this one. So that's what we mean when we say that the two skew lines constrain these two parallel planes. They fix it. There's only one that can actually meet that constraint. So what we'll do then is we'll have a look at how to go about finding first of all the view that we see the two lines as parallel, and how to find the traces of those parallel planes. So we'll start off by looking at our 3D setup here. Here we have our same pencils, and here we have our two sheets of glass, or two planes. So the basic concept of how to find these two planes is basically saying that, well, this plane can contain this pencil. This one here, because it's a copy, should be able to contain a copy of this pencil. So what we do is we take that original pencil and we basically take a copy and we place it on our second plane here, and we attach it to our other pencil like so. So on our 2D drawing, we're going to do exactly that. We're going to take a copy of one of our skew lines and we're going to attach it to our second skew line. And it doesn't matter which skew line we pick at this point. So I'm going to just pick the line AB. I'm going to take a copy of that and attach it to the point D here. I could have attached it to point C, but for the moment that doesn't make any difference. So how do you do this on your sheet? Well, what you do is you get your set square like so, line it up with the first skew line AB, then take your second set square and just slide one off the other to copy the direction. So there's the angle of our copied line. The distance doesn't matter for the moment, just the angle. So this is our copy of our original line AB. So if we've copied an elevation, what we need to do is copy it in plan view. So we've picked AB as our line that we're going to copy. So we're going to take AB here, and we've attached it to the point D. So we want to do the same in our plan view. So again, we're going to move him down to D. And like before, we're going to use our slide and set squares to transfer 1. So the angle, again, all important. The distance, not so important for the moment. And I just might mention at this stage, had we attached the copied line to C in our elevation, well, we'll be attaching the copied line to C in our plan view. So once you've picked one of the points, that's the one you have to stay with when it comes to your elevation and your plan view. So that's our copied line done. So that's like our copied pencil over here. The next thing we want to do is create a level line to make a small little triangle, so a small portion of this overall plane. So if we look at it here, there is our level line like so. And a level line in elevation is going to simply look like a line going straight across. So we've used the line D already to attach our pencil, so we're going to use the other point on our line, so C here. So there's our level line like so, and that's why the length of this line didn't matter, because we're just going to extend it on or cut it short until it hits the line here. So that's going to give us the point x1, and that makes a small little triangle there. This is the same triangle, a small portion of the overall plane that our pencil is resting on. So like we've done before, we want to find this level line in our plan view. So you can see where the point x1 is. We can just drop him down. He's on our red line here, so we're going to drop him down till he hits the red line here. So we can either extend him on or cut him short, giving us x here like that. So x is joined to C, so x is going to join to C here like that. And now the reason we took a level line for our line here is because a level line, when looking from above, is going to appear as a true length in plan view. And we know that if we look along a true length line, we're going to see the line as a point view, and the plane that it's resting on is going to be seen as an edge view. So let's see what we do. So imagine, look at the line here now as we move along like that, and look at the plane as we do so as well. So you can see as we look along the line appears as a point, and the plane here appears as our edge, and lo and behold, the two pencils appear parallel, and we have an edge view of the plane that contains both of them. So in our 2D, we're going to just look along our line like so. There's our auxiliary, x1, y1, perpendicular to our line, and we're going to just project up each of our skew lines. So project up B, he's on the ground here in our elevation, so he'll be on the ground here. A, project him along, whatever distance he is off the xy line here, he'll be the same distance here, and that gives us our skew line AB. So that's going to give us the edge view of our plane that contains the line AB. We do the same then with D. Again, D is on the ground, so D is going to be on the ground here, and X and C are going to be transferred along the same line. They both share the same height, so now they are seen here as a point view. And there's our skew line CD here, and you can see the two are parallel, giving us a proof that we have actually found the edge view of the plane that contains the two of them. So that's how we know that we've actually found the view where the two will appear parallel. So next, what we want to do is finally just find the vertical and horizontal trace for that plane. So let's go back to our 3D here, and let's look at the horizontal trace first of all. The horizontal trace here is where our plane meets the ground. So there's going to be two horizontal traces, one for each plane. So if we look at our object from above, you can see because our horizontal line, and again, one of the other reasons why we made this a horizontal line to start with, because that's a horizontal line and our horizontal trace is also horizontal, we can see that the two appear parallel. And if you look, our skew line here, the bottom point here is actually on the horizontal plane, the ground. So that means that our horizontal trace will actually run through him. So D is on the ground here, D is on the ground here, so we're simply able to go and draw in our horizontal trace, our H1, T1, parallel with our edge here. So you can use your side and set squares to transfer that angle through the point D, giving us our horizontal trace. If we look at it again, B is also on the ground, so we're able to go parallel through B here to give us our horizontal trace in our plan view. So that's our horizontal trace found. Next we want to find our vertical trace. So we'll go back to our 3D view, and I'm just going to put in my vertical plane here. So this is our back wall, if you want to call it that. And what I'm going to do is I'm going to take my horizontal line like so, and I'm just going to simply continue him on until he hits the back wall. And if you look, there's my vertical trace here. Well, that vertical trace there, that's one point on it there. And if we just go back a little bit more again, say, or forward a little bit, we can see there's a second point we have. So there's our second point there. I'm going to continue him on, and what I'm going to do is continue him on until he hits the XY. So if we just look at him like so. The XY line represents the back wall when seen from above. So there it is there. How do I know where to stop when I continue in elevation? So I'm going to just continue that line on. If I bring this guy straight up, there's my continuation, and now I found my point. So that's my point there, located in elevation. I have a second point here where my horizontal trace hits the back wall, so that's my vertical trace there. And because our vertical trace for our second plane is parallel to it, well, we just say, well, there's my point. I go parallel, and now I found my vertical trace. So that's how we locate, first of all, our view where we see the two skew lines as parallel, and how we locate the traces of our two parallel planes. So there's just the two planes filled in. So this is an area where a lot of students tend to have a bit of difficulty with, so hopefully this has been of some help to you. And our next video is going to be on how to locate the shortest perpendicular distance. So this uses or builds on this particular approach. So it's quite useful in areas like mining geometry and surface geometry. So thank you very much, and stay tuned for more videos.